understand toppling through one of the examples. Over here we have an inclined plane. This is inclined at an angle of 37 degree. Even while doing Newton's laws of motion, we have come across number of times of this inclined plane which is inclined either at an angle of 37 degree or 53 degree, because that makes a right angle triangle of sides 3, 4, 5, and this is 37 degree. So always remember it. Be it 37 or this is going to be 53. This is a right angle triangle, so this is going to be 90 degree. So this 3, 4, 5, where 3 is a perpendicular, 4 is a base, 5 is the hypotenuse, then this angle is 37 degree and this angle is 53 degree. So obviously sine 37 is perpendicular by hypotenuse, that is 3 by 5, cos 37 is base by hypotenuse, that is 4 by 5, tan 37 is perpendicular by base, that is 3 by 4. So whenever the angle is given as 37 degree or 53 degree, so you can remember that this is triangle of sides 3, 4, 5 like this. So over here we have this block, the mass is given as 50 kg, this width is given as 1 meter, this height is given as 3 meter, and mu, coefficient of friction between this and this is 0.8, right? And this has just been put over here. So now we are asked whether this block will slide or this will topple. Obviously this way the force is going to be mg sine theta, and this side is going to be frictional force. If this mg sine theta is greater than the limiting value of friction force, this is going to slide this way. If mg sine theta is less than the limiting value of friction force, it is the limiting value of friction force, it means this will not slide. Let's find what is the force which is trying to move it this way is mg sine theta, and what is the limiting value of friction force. Mg sine 37, if you put the values, m is 50 kg, g is, we are taking it as 10 meter per second square only for the ease of calculations. Sine 37 3 by 5, so this comes out to be 300 Newton. So this way the force which is trying to move it is 300 Newton. Now let's find out what is the limiting value of friction force. Limiting value of friction force is mu to n. That comes out of mu mg cos 37. That is mg is here, mg cos 37 is this way. So normal reaction, we have done it number of times in laws of motion also. So this is 37. So this way is mg sine 37 and this way is mg cos 37 and this way is normal reaction, because if we take this as x-axis, this we take it as y-axis, this not moving on the y-axis, so mg cos 37 is equal to normal reaction. So normal reaction is equal to mg cos 37. Limiting value of friction force is equal to mu into n, that is mu mg cos 37. Mu is given as 0.8, m is 50 kg, g we are taking as 10 meter per second square, cos 37 is 4 by 5, this comes out with 320 Newton. So limiting value of friction force is 320 Newton, whereas right now mg sine 37, which is trying to move the body, is only 300 Newton. So it means now this is a case of self-adjustment. This friction force will adjust itself to mg sine theta only. That is, this will adjust itself to 300 Newton only. So we know that this is not going to slip. One condition. So one step is done, that is, this is not going to slip this way. Now coming to, that is whether this is going to topple or not. Let's take the talks about C. If we take the talks about C, it means friction force is this way. We have just done, that is, normal reaction will not be passing through C, otherwise this is going to topple because of friction force. We have just done, so normal reaction, let's say it is at a distance x from this line, it is at a distance x and it is acting in this direction obviously. So if we take the talks about C, so torque of mg sine theta is going to be equal to 0, mg sine theta, and mg cos theta. We are taking the torques about C, so torque of mg sine theta will be equal to 0 because the distance of this line of force from acceleration is going to be equal to 0. So the torque of mg sine theta about this is going to be equal to 0. So that's why I have not written it. Similarly, torque of mg cos theta, that is also going to be equal to 0. So now we have only two forces. One is this friction force acting in this direction, normal reaction which is acting at a distance x from here. If we say that this is, suppose, not toppling, it means the net torque should be equal to 0. Let's find out what is the condition for, that is, the net torque is equal to 0 or that is, it is not toppling. When it is not toppling about C, that is net torque about C is equal to 0, it means clockwise movements is equal to anti-clockwise movements. So if we see over here, that is, if we nail it over here, then we see that this friction force is trying to rotate it this way, whereas this normal reaction is trying to rotate it this way. It is neither rotating in the clockwise direction or anti-clockwise direction. It is, let's say, it is stable over here, or this is in rotational equilibrium. So clockwise movements is equal to anti-clockwise movements. So it means F into this distance. this is line of force, this acceleration, this is the distance. So what is this? This is h by 2. That is, if you are taking a 3, so this becomes equal to 3 by 2. This F into h by 2. That is F into 3 by 2. That is the torque. It is in the anti-clockwise direction. And what is the torque of normal reaction about the point C? This is normal reaction. So this is the distance. So that is going to be n into x. What is n? But n is equal to mg cos 37. This is not going to change. That is not the normal reaction is not changing. It is only that is how it's positioned. The line of force that is changing. So now instead of going like this, which it had been going in laws of motion through C only all the time, because we had taken all the bodies as a point mass bodies. Whereas when we do rotational mechanics, we give due regards, due consideration how the mass is distributed. So over here, these bodies, they are not the point mass bodies. So normal reaction is at a distance x from here. So the torque of this about C is going to be n into x. So n into x. But n is mg cos 37. 50 into 10 into 4 by 5, that is 400 Newton. So if this is not rotating about C, so condition comes out to be like this. So x comes out to be 9 by 8 meter, which is greater than 1 meter. This whole width is 1 meter. So if it has to be in rotational equilibrium, then the x should be equal to 1 meter. But this itself is maximum is half meter. So 9 by 8 meter is greater than b by 2. That is where b is, we have taken, that is b is the width of this block. It cannot be greater than b by 2. If the value of x is less than or equal to b by 2, then only this can be in rotational equilibrium. But over here, the value of x comes out to be more than b by 2. That is, it has to even go over here, which is not possible. So obviously, the toppling begins with slippage, because x is coming out to be more than b by 2. So this will topple, but mg sin theta is less than the limiting value of friction force. So this will not slip. So it means the toppling will begin before slipping.